So problem 2 is asking us to find an expression for the ratio of the radius of the moon's orbit around the Earth to the Earth's radius, or essentially Rm over Re, in respect to T sub m, the period of the moon around the Earth, G, and the Earth's radius R sub E. And it's going to ask us to evaluate at a few different expressions. So one of the key things that's going to help us with this is just Kepler's third law, which basically implies that period and radius are proportional to each other, and so we can use a bunch of the equations that relates to in order to find an expression that has Rm over Re on one side. I'm going to be working kind of from the beginning in my algebra with the mv squared over r equals g times big M times little m over r squared. So, but I don't have time to go into depth about the algebra. So just pause if you want to look at it. I also drew a picture. So just basically one of the things that was tricky for me was understanding when R sub m applies to an equation and when R sub e. So sometimes a picture will really help with that. Okay, moving on. So the first thing is just that Kepler's law info, that we can set those two equal to each other. And you can see once we do the algebra and plug in that 2 pi radius of the orbit of the moon over the period of the moon around the Earth for velocity, we're going to get an equation that is a little bit more helpful for our situation. So, and obviously that equation comes from, once again, like Kepler's third law that we learned about in the unit. So you can see at the bottom, I first squared that velocity equation and then plugged it in, and then I cross multiplied. And I did that simply to gather the radius, the R sub m together, and also to look at what I need to get rid of in this equation in order to satisfy what the problem is asking and what I need to add. And you can see here I need to get rid of big G and R sub m and get R sub e and G, little g in there. So that's going to be where we're going next. So knowing that little g is a constant, we can use the equation of what little g represents, which includes big G, to sub it in. And luckily that equation includes both the little g we need and the Re squared. And later you're going to see that the m of the Earth also will cancel, which is good because the problem doesn't want that in there. So once you do that algebra, you can see we're able to get Rm over Re and factor out the cube. And then all we have to do is just cube root the other side of that equation, leaving us with the expression for that relationship between the radiuses being the cube root of T sub m squared times G over R sub e 4 pi squared. So the last thing the problem wants us to do is just plug in some of the numbers that we're given. You have to make sure, in this case, it can be kind of tricky to remember to convert the period from days to seconds. But once you do that, it's just as simple as plugging things in. And it leaves us with a unit list 60 as that ratio of R sub m over R sub e. So that's the end of the problem. Thank you for listening.